Thanks, Ed. Okay, so the next point on our agenda is something that always crops up in discussions, and that is speed and speedtest.net. And I thought I would give Mark Tinker from CCOM a soapbox to stand on to say how fantastic he thinks speedtest.net is. I'm being sarcastic there. So what we're going to do is I'm just going to quickly invite our three panelists. We're going to have a discussion around Speedtest. So if I can just ask Ben, Andrew, and Mark. See, that's why you need the name tags, so I can remember what's happening. Yeah, so while we just organise that.
Who am I sharing a chair with? How are you? Too much information.
That might put it straight in because I'm hoping that.
Oh, we can start that. We can bring it up.
Okay. So basically, what this is about is an interaction as well with everybody here, sharing experiences, how to deal with this big thing called my internet is slow. Okay, so I think maybe the first thing I want to do is get the guys to introduce themselves, and then I want to ask the question: what do you think? How do you think we should be approaching the industry in general on testing the quality of your internet connection? And should we be letting the public work, always using something like speedtest.net as the go-to de facto test to test your internet link, and take it from there really. All right. So, okay, so also after we've had a short discussion, is that I would really like you guys to come up to the microphone, ask questions, and let's have an engaging conversation between our panelists. Maybe you can ask questions to them and or put forward statements. Okay, you got a microphone there. I'll put that one there.
So intros and answers to that question at the same time, or should we do intros?
Yeah, no, just same time.
So I'm Ben Madison. I work online. I look after engineering. I hate this topic. I really do. So I think the fundamental, the nature of our business is that we provide only wholesale services. We're really just an IP transit provider, and that's it. And so I shouldn't, by all that is right in the world, ever come up against this problem. But nevertheless, I find myself, actually less so more recently, but a year or so back, on an almost like weekly, if not daily basis, explaining to people who had the words network engineer in their job title how TCP works and how TCP reacts to things like latency and small amounts of packet loss and configuration settings on host OSs and things like that. And I kind of feel like if we can't get this right as an industry, to understand why performance is impacted by the things that it's impacted by, what earthly hope do we have of being able to articulate an answer to the question, why is my internet slow, or why is such and such web page quicker over here than it is over there? So I kind of feel like we're I kind of feel like we're trying to answer the wrong question, to be honest. I don't think there is a way of testing the performance of the internet. I think that's a fool's errand, because there's just too many moving parts. I think what we actually, if we're going to spend time working on a solution to this problem, because it's certainly a problem that the operators get nagged with that question on an almost daily basis, and it's the source of a huge amount of support share. But I think we're looking for an answer in the wrong place. I don't think there is a test that we can just replace speedtest.net with and have done with it. I think what we need to do is empower people that work in that role to give an articulate, reasoned response to the question, rather than saying, oh no, I've checked this other speedtest.net server and it's fine, so I'm closing this ticket. I don't know what that solution looks like in details. I'm not sure, but I think that's where we're at personally.
Good morning. I'm Andrew from Terraco and NAB Africa. I was invited onto this panel last night by Donald over drinks and dinner. I didn't think he was being serious. I don't know.
I learned it from Tinker.
I don't know how much I have to say about this. I mean, 3 days ago I super glued my two fingers together, so I'm not necessarily good. Good week, yeah. Our exposure to Speedtest servers, and I guess you could say we're part of the problem. You hear the comments, and it's you know, a couple of years ago when we started with NAP Africa, there was a very popular Speedtest server that published results once a month. And it always turned into a catfight because it was hosted on one mobile networks, network, and of course everybody else said, oh, they're obviously interrupting the traffic or they're slowing it down or something. So the people that run that particular Speedtest server came to us and said, can we put it in a neutral location? Just so that we can get past all of these ridiculous arguments that we have about, who's messing with the traffic. And I guess we did it with the sort of idea that it would be a good way to get people to peer. So, for example, back in those days, the likes of OpenServe and Telkom did not peer. It was policy, and I think it was within a month of us actually moving that onto a network at an internet exchange. Telkom actually picked up the phone and said, we'd like to peer with you. And that's how we got OpenServe onto the internet exchange. And obviously from there they realized the benefits and they started actually getting benefit out of the internet exchange. That doesn't mean that we necessarily think it is a good thing. And if you think about it this way, Speedtest.net has been referenced, but there are all sorts of other speed tests that are going up all over the place. Now I've seen, within the ISP industry, people logging tickets, at random times because suddenly my speed is not as good as it used to be. If you look at it from a home user perspective, as Ben said, there are so many moving parts. There is no one way to test the quality and the reliability and that sort of thing of a line. There's so much that goes into it. And you get into these ridiculous situations where people, end users, potentially choose the slowest one. So they'll do a test to like 5 servers, and they'll take the slowest one and use that to log a ticket because that to them is more important because to that particular server, I'm not getting full speed. I'm paying for 100 megabit, and that one I'm only getting 87 meg. And it's different. And so you'll see a lot of ISPs now are also hosting Speedtest.net servers. The ticket comes in and they say, well, the closest point that I have to you as an end user is this particular Speedtest server over here. So test to that one. People don't want to do that because that doesn't necessarily prove their situation. Having a bad time on the internet and using this tool that you have very little control over to justify. So you end up in this ridiculous circle. So and again I say that we might have been part of the problem, but what is the solution? We've had this discussion with a lot of people, and we say, well, if you want to be taken seriously, if you want to log a ticket, for example, and you believe that you have a problem with the line, make sure that you always use the same one, so that you have a result that is reproducible, and something that is consistent. So if you're going to be jumping around between different Speedtest services, you're proving nothing. And I know Mark's going to have something to say.
Morning. Mark, I'm with CCOM, the head of the engineering department. Should I just want to start with this one? So we had a meeting last year. Was it the AFPIF IRIC meeting in Cape Town with a bunch of ISPs about this issue? It was an early morning one, so most of us made it. And I think we resolved on some action points. And like Ben has actually said, in the last several months or so, we've seen, less interest or less noise. So it could be why we haven't moved much farther since that meeting. But for me now, we're just bored with this discussion at CCOM. We're just tired of it. We're done with it. There's a reasonable amount of fascination about speed tests in South Africa, specifically. Our market is reasonably broad. I'm Ugandan. My internet experience started back in '95 when we only had satellite. That was it. An entire 128K for the entire nation. That's it. So we're reasonably accustomed to how TCP actually works. We had innovative Egyptian companies coming up with all sorts of satellite modems that could accelerate TCP back in '98, '99. Broke a lot of stuff, but for the most part, it was interesting. And we learned how to work around TCP with acceleration and this and that and window sizing and so forth. South Africa for us is the only market where we see this problem. In Kenya, in Tanzania, in Uganda, in Mozambique, we don't have this issue. And the situations really are the same, right? There's nothing special or different we're doing here than we are in those other markets. But I think in South Africa, it probably goes back to the goodness that we had with Telkom back in those days and the level of trust they had, pumping a billion customers down a single STM1 uplink on the DSLAM. I suppose that's where it comes from. The level of trust is not very good. Unfortunately, there's a dime a dozen every week ISPs coming up, claiming to be the best in the world. And so that puts a lot of pressure on them and their customers to prove that the 25 rand they paid for that 100 meg actually works. The Speedtest.net infrastructure, I think, was reasonably useful back in the dial-up days, right? 14.4, 36.6, maybe even the SDSL days, maybe even the HDSL days, right? Maybe some ADSL days. It was useful. Now, it's not uncommon to have a gig coming into a home. How do you test for that practically on a Speedtest.net server? We all have a practical example with how Eskom is overloaded. They lose thousands of megawatts when a hurricane hits the neighbor, and we know what happens after that. These Speedtest.net infrastructure systems are not infallible. And my issue with the Speedtest.net folks at Ookla is that they leave that problem up to the ISPs to solve, because it's a decentralized system. Right, they put out the box out there and they hope that the ISP fixes it and maintains it. But they don't take any kind of responsibility on their system. So now it's the ISP's problem to build and scale out testing infrastructure for customers that don't really, pay into that cost. I mean, if I'm going to build an entire cloud worth hundreds of thousands of dollars just to maintain a Speedtest system, and my revenue from each customer is less than 100 rand or 200 rand in the grand scheme of things, how do we justify that to test something that really isn't practical? So the system itself doesn't scale well. The fact that we have now hundreds of megs or gigs of capacity into the homes, into the businesses, means we can't rely on that system as a result anymore, because when you are testing, someone else is testing also. And those systems are public. So just because it's on your network doesn't prevent somebody from Ireland wanting to test speed between Dublin and Johannesburg using your system, which all your other customers and your competitors' customers are also testing, because they said, Vulcan Lines one works better than the Seacom one, I know this is the result. So it can't scale up. It can't scale up. So how do you then now assure customers that they're getting actually what they're getting when the system is erroneous in itself? We built a large Speedtest Servers and iPerf infrastructure back in 12, which was fine. Because like Ben at the time, we were only doing service provider. We're now, unlike Ben, doing enterprise, for better or for worse. But that means I now have thousands of customers whose only job every morning between 6 and 9 is to speed test. I'm sure they're actually paying some lady somewhere a fortune to just come in and speed test from 6 to 9, print results, get the worst one, like he says, and set it up and say, it doesn't work today. And we got to a point where we couldn't hand over services now when they delivered to customers, because as part of the handover document, you're supposed to show, the line is running at whatever the contract was, which is fine for 20 meg, 25 meg, 50 meg, maybe even 100 meg. When you're delivering a 10 gig service, how do you do that? How do you run a 10 gig service to a server running a general purpose OS that is being pummeled by other users? How do you do that practically? But no, we can't accept the circuit because, it doesn't say 10 gig, it says 8.7, or it says 5, or it doesn't say anything. But at the same time, if you look at a graph linearly, you'll see peaks to about 9 gig got peaked because all the users are working. So where's that bandwidth coming from? Do you know what I mean? So he says maybe they started the problem, I don't know. But what I do know is, at Seacom, for example, our salespeople are fascinated with the monthly, what do the broadband people call it? The monthly
Fastest ISP
stacking, yes, of the month, fastest ISP of the month. And we used to participate in that sort of thing. A practical problem from our side was, before we had Terraco as a customer on the IP transit side, we had a bunch of, we tried to automate this. I think we had initially manual people spending the night trying to run these speed tests to the My Broadband one that you were hosting, so we could come up on top at the end of the week. And then we figured, how do you automate this sort of thing? No, seriously. And then I think Watson over there tried to find a way to automatically move the mouse and click that thing every night. Because that's the only way. And, or was it Tony? Between the two of them. And after a week, we're like, this doesn't work either. We tried to find ways to have maybe some kind of API into the system. We tried to find ways to maybe look at the raw HTML code. It didn't work. And then eventually, to make things more interesting, Terraco became a Seacom customer. So what that meant was, they took a service from us that was not to the same capacity of the link that the Speedtest server was connected to, because that Speedtest server sits on their network, which is now our customer. So now for me, for my customers to run a test against that service, they need to go down their IP transit link, guess what, which isn't 10 gig anymore, or which isn't 20 gig or 30 gig or whatever. So now suddenly the ranking for Seacom goes from whatever it was to non-existent. And my sales guys are like, we're nowhere. I'm like, are you seriously thinking that anyone who knows what they're actually doing would assume that we don't have the capacity to service our customers because we're not in the top 10? I mean, seriously? Until we gave up. I mean, I spoke to him and said, is there any way I can maybe, provide a particular rate limit?
I said to Mark, if you give me a free 10 gig transit circuit, then we're good, right?
Which I did say to my salespeople. I said, if you want to fix this and you think this is worth being at the top, give them a 10 gig port. I'm not going to try and break the network to find a way to fix it, because it's not really important in the grand scheme of things. It's not that important. Right now, we're pushing capacity to customers at rates you can't test for. What do you do with that? So what we decided was shut down that entire infrastructure for the speed test and the iPerf and all that, because it doesn't help anybody. It creates more noise and it solves. Teach our service delivery and pre-sales people how to communicate the impact of latency on TCP to our customers. If they need a workshop, we will do a workshop, and we've done a few. Luckily for us, the majority of our enterprise customers are serviced by resellers, so we teach the resellers and they go and send that message. So we've seen quite a significant reduction in that noise. And what we've also said is, we are only going to test the last mile link. We have no control over what ends up in Facebook's network or in Google's network. I can't guarantee that. What I will test is that dark fiber between you and me, and once that's fine, my core will be guaranteed to provide that up to where I hand it off to another network. So what we did was we bought a couple of appliances from formerly JDSU's company is now called Viavi. They do appliance-based or even VM-based testing. And the reason I like that is because it's a private system. You can lock it down to a specific customer. And that's what we use to hand over the service. Because as part of the process, handing over the service still means you have to show the line is running at whatever meg it was. And those boxes can test up to 10 gig. But because it's a private service, you need to authenticate the actual test. Then you know you're not getting pummeled by all manner of user. And we have that deployed in Joburg, Cape Town, and Durban. And we're going to use that specifically just to qualify the last mile link. Doesn't include any testing between here and London. Doesn't include any testing between here and Beirut. If you want that, sorry. I would happily leave your business because I don't want the headache. And that's what we're doing now. And we've seen, I mean, to be honest, we've brute forced it into the customers, but we've seen a measured response now. We've seen more articulated responses from network engineers that actually, can now troubleshoot something, before they bring this issue up. But our position right now is that we're done with the speed test game. It doesn't work, and the ultimate solution for us as an industry here is to bring the content closer. If the rest of the world thought that you could speed test your way to success, you wouldn't have Facebook, Google, and Amazon, and Microsoft, and LinkedIn, and Netflix building submarine cables around the world to get closer to their customers. They are investing in those systems for a reason, to bring the content closer, and that's the only solution, right? Microsoft just launched their local Azure instance a couple of weeks ago. We weren't pairing with them previously because it was impacting the customers in East Africa. They're coming in and going back out. But then suddenly customers said my latency to local Azure is 110 milliseconds. So we fixed that. Then it came up that there's now an Azure network speed test thing that's 49 milliseconds on MTN versus 120 on CCOM. So I said, that doesn't make sense. So you walk up to Microsoft and they said, well, actually that resolves to an IP address in Amsterdam. So how someone in South Africa is getting 49 milliseconds is beyond me. I'm like, yeah, you figured. But customers will conjure up all sorts of drama to make it interesting. But because Microsoft are now here, that is the ultimate solution to our problem. Nobody ever complains about YouTube quality or Netflix quality because those services are physically here.
Thanks, guys. Mark, I think you brought up some interesting points there. I think the last one is one of a really good one, and that is bringing the content closer. And then the other point was about latency and this idea of having a workshop, understanding what latency does, and maybe if we have time we can go into it later. But what I'd just like to do is at this point open up the mic to the floor. I think Graham, you have a question to start with.
Hi there, Graham Baker from SA Digital Villages. I've obviously seen the same thing going on in my networks for many years, and I've experienced some of the same frustration that you have. What I've seen is that there is a trend towards people improving their understanding of these issues, but what still frustrates me is that so many of these tests are ultimately synthetic. They're not testing a real user experience, they're not testing a real use case. I actually was dealing with an issue this last week where a customer who understood that latency was a thing and it wasn't just about speed test and he decided that the latency target that he was wanting to test to was pool.ntp.org, which happens to be about 3,000 different DNS records in a round robin. And he was insisting that he was pinging a server in the Netherlands, I think, and he actually wasn't. He was actually pinging a server in New York, and there was this backwards and forwards for a number of days because he was insisting that this was the metric that he was using to evaluate, and that latency to Europe should be X, and he was getting Y. So there's still a lot to be done in terms of the education, but I think we are at least making some progress there. But for me, I think the important thing, and it goes back to what you were saying about the content. At the end of the day, in parallel, I think in the same ticket, that there was a query around the latency to CNN.com. Now, CNN.com is hosted on one of the CDNs. I don't recall which one, but it's on one of the CDNs. It's present in Joburg. And so there was tests being done to CNN.com, and they said, oh, well, that's wonderful latency. That's an international site. Why is everything else not the same latency as CNN.com? And you have to go through the whole process of explaining that. But the question of what are you actually using your connection for? What do you have in the Netherlands or in the US or New York that you're actually trying to get to? The only situation that I've seen where this legitimately actually comes out in the real use case is either a game server that's located in those regions or a big international corporate who's got some specific WAN-based thing to reach some mothership in another country. Those are the only two real business cases that I've seen, and then alongside of it some pirate content, people trying to stream from funny countries to get pirated content that they can't get locally. There are very few other reasons that people are actually legitimately, as mainstream consumers, actually needing to reach infrastructure in another country anymore to a large extent. And I'm not sure whether you're still seeing a lot of demand for real world usage or if it's just synthetic tests to try and prove some point on some. I mean, Andrew, you've probably seen the trend of the localization of traffic, and people still seem to place a high regard with the international performance of your network, regardless of how much it actually affects their day-to-day usage.
Yeah, so I agree with everything you were saying. So the synthetic nature of the test is, I mean, this is kind of why I was making the point that I made at the beginning, is the synthetic nature of the test is totally unavoidable if you're searching for a test. You know, Speedtest.net is wonderful for measuring your performance to a specific Speedtest.net server using the Ookla application. That it'll measure that performance completely accurately. It'll measure almost nothing else, unfortunately. You know, and this idea that we've got of selling an internet service as this linear thing that connects two logical points together and can be tested in a linear fashion is just wrong. There is no linear test that can solve that problem. And that's why I think the approach that Mark's taken sounds very, very sensible. You know, test the part of the network that is linearly, and then put probe-based monitoring to make sure that you're meeting your SLAs elsewhere. You know, that's what we do. Our SLA says that your latency will be X and we won't drop packets. You know, and we measure that. And as long as we're doing those two things, then solved.
Right, so we have a
Yeah, just to comment on what you're saying. So yeah, the use case we have for the corporates is we're seeing mushrooming of compression service providers. There's one that was working with us the other day. I think they call it Accelerate something. And that's for that specific use case. Corporates that have head ends up somewhere else and they're here and they have devices in between. But obviously the market is there for that because they can't overcome the latency.
Yeah, I'll just add latency is important. What Graham said is that you say that the market is becoming more educated. I think potentially there's a sort of a band where the market gets to a point where it's dangerously educated, where it doesn't necessarily get embedded. If you've got a little bit of information, you tend to make a lot more noise about it. Mark, you mentioned the Azure region. we had a lot of conversations with enterprises about latency. You know, when the Microsoft Express Route connection point came, you know, everybody just said, "Oh, we're not interested in the cloud because the latency is too high." And we said, "Okay, well, what is your use case?" You know, get back to the whole thing about use case. You know, we said, how much latency do you need? Well, I don't know, but this guy that I know who plays games says that it has to be as low as possible. So, yeah, it's got to be that. You know, so there is just a big misunderstanding about it.
Sean from Rocking Connect. So, I mean, we deal with this kind of stuff all the time. We recently had a VFX producer in Cape Town, gets Hollywood clips, does all the VFX stuff, and has to upload it via FTP to a server in LA. Had a huge fight with us, pretty insistent that at some point he got a speed test to LA and he was getting 40 milliseconds. And he's going to stop paying us until this link is giving 40 milliseconds between Cape Town and Los Angeles. We initially started responding kindly, and then it's descended into a pretty much you're an idiot and take your business and go away. We don't want to deal with you. I'm just interested, like, what kind of responses? I think one of you mentioned just now. It's more about with you, like, articulating. How do you explain this to clients? Like, do you guys do it at the outset? Like, here's your service. You're going to speed test. We're responsible for this part. You know, talking about that linear thing, and that's pretty much what we do. It's like we're responsible from here to here. You know, it's the internet, dude. There's like all kinds of weird, wonderful things that happen out there. I had another client trying to test to the Caribbean somewhere because they were, I don't even know what they were doing, but they were getting like, I think 600 milliseconds. And I was like, yeah, good luck, you know. And they're like, oh, but we need like 50. You know, like light works. You know, there's like the laws of physics. So just some like practical. Just hearing it from somebody else often is useful. Just like, what do you guys? How would you counter something like that?
So I think you've got two potential solutions. So the one involves having a conversation about propagation of light through silicon, yeah, which is the obvious response. The other is you just spin up a VM in Cape Town, make the reverse record LAX dot something else, and tell him to ping it. Because he's clearly not that bright, so that might work.
Yeah, so, well, for us, the knock obviously will open a ticket for just about anything. So you know, they'll open a ticket, they'll troubleshoot the case until it gets to a point where, well, you know, we don't support the result that you're getting because that Speedtest server is off-net. Sorry, bye. But they will troubleshoot the case and try and fix it, because ultimately the knock for us anyway is very kind and they're very patient, a lot more than some of us here. So they actually will work through a problem even when they know there's not going to be a real solution, because it's in their nature to just be hospitable to customers.
Hi, I'm Alan from 365. So maybe just a comment about Speedtest. I don't want to be the guy defending it, but I have actually used it in its what I think is its proper sense quite a few times and gotten some good results out of it. And maybe the analogy to use here is that it's a bit like giving a bandsaw to somebody. You know, one guy will make a beautiful piece of furniture, another guy will cut his fingers off. I mean, they could have used your super glue, I guess, for that. But you know, in this specific instance I'm thinking of, we had a customer, actually a CCOM customer as well, an ISP who was struggling with slow international traffic, and you know, we looked at that, and the first thing you think there is obviously latency, TCP. These things jump out. But using it properly, we actually started to realize that the latency, as soon as it went over around about 70 to 80 milliseconds, across various destinations, we suddenly saw a massive drop-off in speed, which is not what you'd expect. And when we tested other customers with CCOM breakouts and transit in the Greater Joburg area, we saw not the same case. So, you know, using that information, we were able to deduce a problem in a quads. There was actually a burstability issue in one of the quad settings that they had on the Juniper. And there was probably other tools we could have used, but this was just a really simple one that we could use. And I guess the point is that, and more to what Ben was saying earlier, if you understand what the test does, it's still valid. The problem is that it's just so generally available to people that the misinterpretation chance is way, way higher than probably is acceptable to the industry.
Well, it's more than just a chance of misinterpretation. It's false marketing. It markets itself as giving an answer to the question, how fast is your internet? And I've absolutely used it, and lots of other tools like it for similar scenarios like the one you just pointed out. You know, you test 8 different speed test servers all purporting to be in London, and one of them has double the latency reported. That may not be a problem in and of itself, but it's potentially worth looking at to find out why you're getting that result. The issue with it is there's very few things that are a completely worthless test if they're giving you metrics that you can either use for comparison or they tell you something you didn't know. But what it doesn't do, but what it claims to do, says, you know, your internet is either A, B, or C. You know, that's my issue with it.
Maybe just one other quick comment as well is perhaps something that's not commonly understood is that on ISP networks where you're shaping, specifically shaping at layer 7, your speed test is almost entirely unshaped, but the rest of your traffic is probably going to be shaped during peak time. So there's maybe a misunderstanding that will happen from a customer's perspective where they're like, oh, my speed test is fast, but my internet is slow. Maybe that understanding is also another challenge that we can go through.
So I want to talk about the use of the term shaping. And this goes to what Mark was saying about telecom and back in the day with ADSL. Good luck operating a network that is not using buffers to hold memory packets in memory between an input interface and an output interface. All shaping is doing is saying, fill the queue, use those buffers at some number other than line rate. Yeah? You with me? You have to do that, because if you stick a policer as opposed to a shaper in the middle of the internet, things will break hard, especially when you have large round-trip times. Unfortunately, Telcom's marketing team, for whatever reason, and lots of other retail ISPs at the time as well, but it was mainly Telcom, decided to use shaped as a synonym for this is going to be rubbish. And as a result, people hear I'm being shaped, and they don't hear like, you know, perfectly reasonable engineering solution to a real technological problem. They hear, oh, this is going to be rubbish, you're making my service rubbish on purpose. And that's simply not the case. There is either a hardware shaper or a software shaper on every interface on our network, without exception. The only exceptions being ingress policers facing customers who have specifically asked for the throughput penalty as opposed to the latency penalty. And that's really the only use case. If you're not shaping everywhere, then either you better be running line speed everywhere, or you're doing it wrong.
No, totally agree. Totally agree.
Hi everybody. My name's Malcolm. I'm the second chief troublemaker after Michelle. I've got 2 very quick points that might fundamentally change the way everybody thinks about this. Point 1 is, how many people in the room have the Speedtest app installed on their phones? That's quite a large majority of people that would potentially walk into a room and say, oh cool, there's Wi-Fi, let's test it. So the de facto standard of using speedtest.net just suddenly arrived into this country because people were doing it, and everybody said, have you looked at speedtest.net? I can check my connection, it's so cool. So how do we as network engineers, I suppose this is what the talk is about, how do we tell people that that's nice and everything, but it's not right? That's point number 1. And my second question is around, you know, potentially doing more, as you mentioned, to talk about how latency actually affects connectivity. A lot of people would know that if I throw a ball from here to here, it's going to take a certain amount of time to get there and for you to throw it back. But if I stand at the back of the room and I throw the same ball, it might not get to you, either because I'm not throwing properly, or because something else is in the way, or etc., etc. So how do you tell people that there is this thing called TCP window sizing? It does affect latency. It can be a problem when you're in America to go download your things, and maybe that's something that we can do in terms of teaching. That sort of education is better than just speed test, it'll work. And the third point is, and I don't know if anybody saw my presentation on this, I just cache speedtest.net as a service locally. So if you want to test 10 gigs, it's very simple. You got test, the world's a happy place.
Just on your first point, you said people walk into a room and say, "Oh, there's Wi-Fi, let's test it." Of course you do. I mean, it's because you work in the industry, you're interested. But I mean, did you do a speed test here today?
Yes, that. Yeah.
Okay, and did you pick up the phone and complain to CCOM?
I wrote a snotty letter to the line.
Yeah, exactly. You see, and that's not the thing. I mean, speedtest.net is great for things like that. People use it, for interest. And you might be able to use it for troubleshooting if you understand.
I wasn't talking about that. Sorry, I was talking about the layperson part.
Malcolm again. I'm talking about the layperson, not the network engineer who has speedtest.net. I'm talking about the layperson who has speedtest.net and goes to his friend's house, and then his friend's house, and then, oh look, your connection's slower than mine because. Yeah. Okay.
Yeah, so in October of, I think, was it 16, we elected to sponsor the Wi-Fi at the Microchina Forum, whatever it was, the one in Midrand. And we brought, 20 gig of capacity to the site. It was maybe, 5,000 odd participants that rocked in. We deployed 50 Wi-Fi access points. I think at the time, N was the fastest we could get, and we also provided points for cable, for those that wanted to come with their games and so on and so forth. So I think essentially the average feedback, we polled the room throughout the 2 days, was that the Wi-Fi was shit. Because people would walk in and the first thing they would do, it's free access point, free SSID, boom, speedtest.net. And I think in that particular instance, the speedtest.net server probably wasn't the limitation, it was the Wi-Fi. And the fact that maybe there was no AC at the time, and most people were still on 2.4 as opposed to 5 gigahertz, etc., etc. The point I'm trying to make is that there are some things that you can't really teach, and I think it's a futile attempt because ultimately the customers don't care, right? And to be honest, they really shouldn't have to. And that brings me to the second question, where the better solution would be to work with the Microsofts and the Facebooks and the Netflixes to develop tools and applications that test performances to their actual services. The stats for nerds and the whole YouTube thing. If you like that sort of thing, you can right click and pick that, will show you, all manner of data. That for me is much more useful. And that's an evolution we need to move towards and away from the whole speedtest.net culture. We need to now start going into the actual service. When you take a service from Microsoft for 365, or if maybe on the Apple TV or PlayStation app or whatever app for Netflix, is there some kind of extra tool, extra tab that tells you about your actual performance through that service, as opposed to how fast is my pipe from here to Netflix, which doesn't really tell you anything. I think that's where we need to take the discussion to, and I think trying to teach the layman about how this stuff actually works, in my opinion, is not going to help him there.
Okay, are there any other questions at the moment or comments? I think just from my side, maybe just we'll go through again. What I'd like to ask you is, we've spoken about the amount of bandwidth, so the speed, and then latency. When, as a network engineer, when you're troubleshooting a performance issue on the network, what are the other things, the other points that you think they should be looking at?
Okay, so in my life, my give a shit layer is layer 3. Yeah. So, for stuff that I have to properly take seriously, as in it can impact relationships with customers, We need to care about latency and packet loss, and availability as measured in some very complex way that we've got to measure it. If I'm troubleshooting something higher up the stack because I'm a nice guy, that becomes a much more complicated question. Because layer 3 is the simple bit. That's where the simplicity comes from. And it really depends. It's all application specific, because every single use you have for the network has a slightly different path all the way through these layers. So a lot of stuff will use TCP, but by no means everything. Some people will recreate a kind of an acknowledge response model on top of UDP further up the application layer, etc., etc., etc. So the first thing I'd do is, if it's not a well understood protocol like HTTP running over TCP, I would seek to understand the nature of the protocol that I'm looking at. If it is something well understood, like a simple kind of HTTP speed download problem, then one of the so it might be worth just touching on why latency is important, because a couple of hundred milliseconds is not even really detectable by humans. It's not that delay from initial request to initial response that's the problem. The problem is the way that protocols like TCP respond to the existence of round trip time. Because whenever you drop a packet in part of a TCP stream, that packet needs to be, that loss needs to be detected. The sending side needs to become aware of it, and they need to stop what they're transmitting and transmit that missed packet if you're lucky. If you're not lucky, they will just go back to where the loss happened and start again from that point if you're using some old operating system. And there were so a really good resource to start learning about this sort of stuff is a website that's maintained by the Energy Science Network guys in the States, and I can't remember the exact URL, but it's something like es.net or esnet or something like that. If you Google Energy Science's speed iPerf, so those guys wrote iPerf 3, so they know what they're doing. Well, over TCP they don't. It's broken it's broken with UDP. They've done studies, and other people have done studies that show that something like 0.01% packet loss is virtually undetectable if you're talking about a intra-metro kind of round trip time of sub 20 milliseconds or so. As soon as you get past 50, 100, right up to 200, even that kind of minuscule amount of loss, which is present on pretty much every packet-based network, there is no loss-free packet-based network, becomes that the effect of that gets amplified and amplified in an exponential fashion. So one of the things that I would immediately look for if I was faced with troubleshooting this over some distance is I would be asking myself the question, is there some kind of background loss that we're only seeing a performance penalty for beyond a certain latency, but it's actually
with the Azure and the AWS direct connection stuff that's happening. People will connect into the cloud. The first thing they do is they turn up a server in the cloud and they run iPerf across it. And that when they are going to an out-of-region resource, it becomes difficult. And then we start having the exact same problems, because you're sitting 168 milliseconds away, and you've purchased a 100 megabit circuit and you can only get 10 megabit. There must be something wrong. So we do have the exact same latency discussions. We also have to have a look at layer 2. Some of the cloud providers do some strange ECMP stuff, which doesn't always work. And also what we found, we had one where a client had purchased a 500 megabit circuit, but deployed resources in the cloud that were only certified up to 100 megabit. Yeah, and because we don't have visibility into that, it just turns into a ridiculous backwards and forwards game. So one of the most important things when troubleshooting a problem, gather as much information as you can, and as Ben said, try and understand the protocols that you're looking at.
So for us, we've seen routing actually to be one of the factors. We've come across cases where it's actually faster to go through transit than peering. You'll find that a customer will say, no, it's a lot faster through work and man than it is through CCOM, and when you look at the trace routes, you actually see one's going through peering, one's going through transit. Then we have to now make the call, commercially. But what Ben said, and also what Andrew says, is for us, I think really packet loss is one of the most important ones. Because if you don't have that, that's a good place to start. Once you have packet loss, like Ben says, it just exponentially gets amplified. So fixing packet loss is a big, big deal. And then everything else that they've said. In rare instances, you'll consider different services, as in circuits. I think we recently heard about the SAX cable, a South Atlantic whatnot cable system that goes through, I think, Fortaleza, and then Sao Paulo, and then Miami. Anyway, we got emails from a bunch of customers saying, oh, we've got this new cable is coming up, it's going to cut latency to Europe by 100 milliseconds, whatnot. When are you going to join? We're like, yeah, I'm not interested, really. So why? Everybody's getting on it. No, not for us. And for us, the reason was, I think between Cape Town and Miami was what, 200-ish, 220-ish, give or take. But then after that, the actual services you're going to look for are inland. They're inside the country, they're not in Miami. We have a couple, but like gamers want the stuff that's probably out in Chicago or out in Ashburn or wherever, and that's a further, 20, 30, 40 millisecond, versus the Americans have moved everything over to Europe, which is 140 milliseconds, and now they're moving some of that stuff further down. Why do I want to invest in a cable system to America? Unless the US government is going to pay me hundreds of millions of dollars to connect their bases, I don't care. So, it's those sort of questions. Do you now take on a new cable system to get to a market that's not interested in that anymore? The core of the internet is no longer in the US, and the gamers need to pressure their service providers to get on board and bring the games into Africa.
Sorry, Mark, I'm just going to ask if you can just, because we're starting to run out of time, just one last question, and then we'll just wrap it up.
Sure.
Basically, I have spent...
Sorry, your name is, and you're from?
My name is Rowena. I work for myself, and I spent 7 years working for Toyota, and our mothership was in Japan. So there were a lot of questions from users about why is my internet so slow? I'm trying to update a database in Japan, and I can't, get any responses. So one of the things that I come from an IT audit background, so I'm used to testing things in a very methodical way, because you've got to be able to reproduce that. So that's what you're basically trying to get to your users, whoever they may be. Are you testing something at a point in time? You're using speed test. You're testing it at one point in time. You're never going to be able to reproduce that point in time again. So let's rather look at consistency, or let's look at another way of thinking about it. The other thing is finding that point of failure. You've got, you're always looking for that lowest common denominator, exactly what you were saying about, you put in a huge infrastructure and then you've got one piece of that infrastructure that's limited to, dial-up speed. It's never going to work. So it's finding those points of failure as well, and explaining to your users in a brief way what the complexity is as well. So you're trying to simplify the information for them. It's like if they are going to say, oh, but I tested this, it's like, well, what's the wind speed in Tokyo right now? It's different to here, but at the same time, you're also looking at context. If somebody's trying to do something on Black Friday, good luck. Just explaining to users context. We had a tsunami take out all of the connections while I was there, and I had a discussion with the head of IT at the time from Japan, and I said to him, we're having load shedding, we're having all these problems, people stealing nuts that take out the whole factory's electricity. And he said, we don't have those problems in Japan. Anyway, needless to say, they had other problems. But it's, what is the general context? Is it, because you said there's so many moving parts, but even trying to get your users to think a bit broader so that they frustrate themselves less. Those are my points. Thanks.
Tony promised he's going to be very, very short because, we are running out.
Tony is short.
We'll come back to that. I just want to add...
Sorry, where are you from?
Yes, hi, sorry. My name is Tony. I'm with CCOM. And I just want to add the RANds, research institutes that have their own network, and they use a tool called Persona to kind of monitor the performance of the infrastructure. And it's quite a detailed monitoring tool. And that's probably something that network operators should consider using and extend it to services that they provide to customers. That's my point.
All right, we did have a question remotely, but unfortunately we have run out of time, and I think it just goes to show, though, that it is a very lengthy discussion and topic. So just to wrap it up, I think some of the things we can take away from this is understand the problem that you're actually trying to solve, and on a ground level, make sure that your network is running, optimally, routing, no packet loss or minimal packet loss, low latency, and I think, would you agree that something on a higher level, something like MTU can start to cause issues? I think people spoke about TCP windowing. So yeah, I think it's great that we had the conversation, and we're having a discussion tomorrow about network management and monitoring, and I think this is, we could take some of these things to say, what do we need to monitor? And start with that question tomorrow. So thanks.
Monitor the Wi-Fi, apparently.
All right, thanks very much, guys.